Greetings, sentient being, and welcome back to another episode of Punkworks. I'm Pluto, and I'm gonna hopefully teach you something today. Maybe, maybe not, I don't know. We'll see. Today, I'm very excited to show you a project that I've been working on for the past couple months. Well, a little bit longer than that. Honestly, it's been a project on the back burner for ever since I was a little kid, playing MUDs. As a kid, growing up playing MUDs on the internet, I was fascinated by Telnet. How everybody could get together and play like D&D and stuff over the internet. It was just the coolest thing in the world to me. But I never really dug deep into that sort of thing until recently, when I started playing Greyhack and started messing around with the blockchain system. Like I showed you guys the credit system. Like, you remember, credit, people bank their money with credit, and you use this to, have restart insurance, and it uses the game's blockchain API to facilitate this. You can do all this stuff without needing a secure shell or FTP or that sort of thing. It just goes through the blockchain, and that's what we're going to be doing today. So I want to show you real quick. When I open up credit, you see there's an MOTD. I can update this as much as I want without having to recompile the credit app. It all goes through the subwallet info. Let me show you what that looks like. Okay, so here you can see, actually let me restart this real quick. Okay, so here you can see the MOTD, and here you can see how I update that. I simply write to the subwallet info those lines, and whenever you start up credit, it checks this subwallet in particular. You can see there's nothing really, there's nothing here you can do anything with. Like, you already know my wallet address because you buy coins from me, and other than that, you can't do anything with that information. So this is what everyone's subwallet looks like. It has this information right here, and then this is empty. But that won't be the case for long, because I'm going to be putting this sort of thing in your subwallets as well, so that you can have messages. Okay, let's see what happens if I change the info. So we're going to edit the info, and we're going to change, because lead update now has a mirror server, so we're not waiting on it. It's now up. So let's go ahead and inform the masses. Done. Okay, so let's see what that looks like. Quit out of there. Go back in. And the MOTD has been updated. Okay, now anyone in the game, anywhere that they are, that opens up the credit app now is going to see that. They don't have to connect to a special server. They're just connecting to the blockchain that everyone has access to. Oh yeah, quick plug for myself. Remember, I'm at Punkworks. There's an at Pluto on YouTube. It's not me, okay? So don't at this person expecting it to be me. They're someone else, all right? Leave them alone. Let them live in peace. Okay? If you want to harass me up here. Thanks. Okay, anyway, let's back to the show. Okay, so what are we actually doing today? Today we're going to talk about TCP. We're going to talk about what is a socket. We're going to talk about subwallet info, the game's crypto subwallet info thing. And we're going to talk about how they all work together. How I'm going to use subwallet info as the transport medium for my little TCP-like system. Call it a transport layer. It's not true TCP, because true TCP simply won't work in Greyhack because of the transport medium that we're working with, the subwallet info. That's why it's asynchronous, is because of the transport medium that we're working with. Let me show you here. Anyone can be sending or receiving at any one time. You don't really, know who's going to be doing it at what time. So it's handled asynchronously. The subwallet info can only hold so much, so it's prone to being overwritten, you know, which is why we need a stateful packet-driven system so that we can act those packets, and if those packets aren't act, we can retransmit because we're storing them, you know, in memory, and if we don't see the acts that we're looking for, you probably can't see them because they're kind of tiny here, then we retransmit. And that's actually something that we need to work on because I've kind of ripped that code up a couple times and torn it out. So I'm going to tear this out again and going to tear that out again, and we're going to rebuild it, make something better. When we talk about sockets, we're going to talk about, you know, how they work in the real world, and then how we're implementing it into Greyhack. You know, how we're going to kind of emulate that by creating packets and packing those packets and then sending them into a socket. We're going to sync up. We got all that stuff that we're going to go in through. Let me see, where is it? Yeah, so all that stuff. So we're going to go through all of that and talk about how sockets work. And then we're going to talk about how the subwallet info works. Let me find that one. There it is. Okay, so hey, let me show you that real quick. Here you can see we have, there we go. Now you can see the full packet. And you can see this packet has a bunch of white space in it. Right there, and then right there. There's nothing written there, it's just empty space. Okay. This 64 right here indicates the payload length. This space right here is 64 characters long. That's our current payload. You can only fit 256 characters into your subwallet info at any time. So we're reserving 156 for our packets, and then the rest is for subwallet metadata. And then over here is going to be in-app purchases. This is your insurance if you have any, and this right here is going to be if you've purchased a custom username, which we'll get into the in-app purchases later. It's just going to be game money, but since it's Greyhack, I'm going to make it stupid, where you have to like buy a username. You can chat for free, but if you want a username, you got to buy it. You want custom colors, you got to buy them. So yeah, we'll get into the evil shit later. For right now, we have a packet, and this is how it's structured. You have a signal, you have a version, and this is your transport flag or session flag, like sync or ack, terminate, reset, that sort of thing. That's actually what, if we go back up here, if you kind of take a look, if you ignore that part that came later, if that would have started with that, it probably would have been Project SATR, but it's Project SATR. Sing, ack, terminate, reset, also known as Stateful Asynchronous Transport. See it? You see it? Now over here, we're sending packets in order. We're kind of tracking what sequence we're on. So this one is sent 13 packets, and this one is sent 17. So if we look down here, you'll see 16. They are numbered 0. They start at 0, so 16 is the 17th packet sent. And then this one, when it sends a message, it expects that the next one that it sends, like if I send a message right now, it's going to expect a 13 acknowledgement. Okay, so let's go ahead and send that. Okay. I've got it slowed down a little bit for testing, that's why it took so long. It'll be faster in release. But, okay, so we expected a 13, and then there's the 13 right there. That's the acknowledgement that was received for that packet. And so the next one that we send will be a 14, if we go ahead and do that. And you can see it updated, and I know it's kind of small, but trust me, that says a 14, and then corresponding over here. Okay, and then if you were to send one from the other side, that one's going to show, there it goes, Okay, so you can see that it incremented by 1. And if we send another one, it's going to increment by 1 again. There you go, 18. And then this stays the same though, because that's the acknowledgements that we're at. This is the acknowledgements hasn't changed because this person hasn't sent another message yet. Now if we do send another message, okay, then you can see it has changed. Now remember, these are two different ones, so this is going to be like that. Okay, so if we send another one from over here, takes a second, you'll see that if our last one was 18, then that one's 19, that one was 14, that one was 15, and so every time we send a transmission, the sequence of our transmissions goes up by 1, and then the acknowledgements are, well, when we send a transmission, the acknowledgement matches the sequence, and then our sequence increments by 1. So we sent sequence 15, we got an acknowledgement for sequence 15, and so we incremented our sequence to sequence 16, and then that's the next one that we send. And that's just, you know, you send the packets in order. There's no real like weird math or science to it. It's just 1 plus 1 plus 1. But if they get out of order, if you get, you know, if you're expecting packet 21 and you get packet 13, or it would be, sorry, if you expect packet 21 and you get packet 23, you know, you're like, where's packet 22? So resend that. Okay, let's do a little coding. Let's make ourselves a little mini socket class that we can make a little mini socket object out of. Now, we're not going to be coding the entire Project SATR on the side. That's not what this episode's about. This is about the little pieces. We're going to construct a socket object. Right, so our socket object's going to start off with, you know, a map. That's how they do, and then we're going to give it a class ID to make sure that everyone knows that it's an object. We're going to call it socket because that's a good name for it. From there, we give it our standard socket, you know, attributes, which is going to be, you know, ACK, sequence, and are we connected or not. That's going to be the most important things, like, are we authorized to send data, and then are we appropriately tracking our data. The next logical steps from there would be to make a send and a receive function. So let's go ahead and do that. Send, it's going to be, oops, there we go. And we're going to take some sort of message, you know, just like up here, some sort of message to send. Okay. We're going to put a placeholder. So two ways we're going to do this. We're going to start off doing this with a file. So it's going to use set content. And then later we're going to switch this over to using subwallet info, in which case this will be using set info. Okay. And with the send, we don't really need to return anything, so we'll just return null, or we could just leave it out. I just have a thing with always return something, even if you're returning nothing. If that makes sense. Anyway, socket.send, if I can type, receive, there we go. Yeah. Okay, there we go. Now it's there. Anyway, so from here, it's either going to be get content when working with the file, or get info if we're working with the subwallet. And this one, we're going to get some sort of data, we're going to parse it, and then we're going to return that data. Okay, so this one we don't need to return anything. We're giving it an input, and it's going to send that away. It's going to write stuff. So that's where its output goes, either into a file or into subwallet info. This one doesn't need an input. Its input it's going to get from either the file or the subwallet info, and then it's going to return the data part, the part of that that we need. We're going to start with a file for our socket, as mentioned before, so the first thing we want to do is actually get that file that we can work with. Let's see, we'll call it socket file equals gotta slow down sometimes, sorry guys. And we're going to call it a socket. Okay. There we go. Okay, the file's there though, because we already made it. Okay, so we're going to go ahead and use this file as our socket, so when we set content, that's what we're going to set the content to. So it's going to be socket.socket file.set content. Let's just call it packet. Okay. Okay, so the packet itself is going to be made up of the message and then a bunch of metadata. So the first thing we're going to start with is packet equals that. Actually, I'm sorry, no, we're going to start out with packet equals let's give it, you know what? For now, for testing purposes, we're just going to start the packet off with our sequence ID. Okay, so we don't actually have one set. We're just going to default to that. So it's going to just start out with that. The next thing we're going to send, next logical thing would be the flag. So we don't have any flags yet. So let's go ahead and add. We can start off there, and then we'll have an ACK flag and a term flag. We'll just start out with sync, ACK, and term. So we'll start out with sync. So we're gonna go ahead and packet equals packet plus the flag. And then we're gonna put. Now, if you were building this to make multiple sockets in a single script, you're probably going to want to use, oops, wrong one. You're probably going to want to use self instead. That was supposed to be packet, I'm sorry guys. You're probably going to use self instead and then have like a constructor and some other stuff like that to return a discrete socket object. We're not doing that in this particular example. Just going to keep it simple, but just keep in mind that there are most certainly, generally speaking, you would actually want to use self in this case and then have a whole constructor and then return a discrete object. But again, we're just not going to do that because it's miniscript and you don't fucking have to. Okay, so next step, packet plus the sequence. And then we're going to pack on just the number 16. That's going to be our payload length. It's going to be standardized. Plus message. And then finally we're going to pack it, or cap it off with the end of packet marker. Okay? And then we're going to set content to all of basically to that. It's all going to be one string, and then we're going to set content. Okay. Additionally, if we weren't syncing, we would want to increment sequence by 1. So what we're going to do, if the socket.flag does not equal sync, then socket.sequence equals socket.up sequence sequence. Now, just remember, these are strings, so if we want to increment them by 1, we're going to need to convert it to an integer increment it, convert it back to a string, and then make sure it's 2 digits. So we need a function for that. Okay? So let's go ahead and type that one up. Let's call it, yeah, that's right. We're going to call it socket.upSequence, socket.upSequence, and then we're going to get an input. We'll just call it S. And then, so S is going to get S dot to integer. And then what we're going to do is S equals S plus 1. And then if, and then S is, actually we'll just be slightly more efficient. So S is going to be the string of S plus 1. So once we get there, if S dot length is less than 2, then S gets a 0 tacked on to the front of it. And then we're going to return S. Cool, right? So we get a string, we convert the string to an integer, we increment it by 1, convert it back to a string, and if it's a single character, we make it 2 characters. Now we're not quite done. And here's why. Let's see. If S is equal to 100, then S is equal to 0, 0. We just want rollover. Another way to do this, we could also just put it, if S is greater than or equal to 100, or actually, I'm sorry, 99, then we would increment it. So 99, then S equals 0. Okay, and then we could remove this one. So then, if S comes in and S is the number 99, then the next sequence is going to be, oh, actually, no, I want to do -1 on that, because that way we can do S plus 1 gets it to 0, turns it into, and yeah, so we want S equals -1 to reset, just for this one in particular. We can do it other ways, but we're going to do it like this. Now that we've done that, this will work right here. We can now increment the sequence after we send a packet or send a message, as long as we're not in sync mode. We don't want to ACK that, okay? Which brings us, of course, to receive. We're going to want to get content. So for there, it's of course going to be, we're going to call it raw, because it's the raw data before we've parsed the packet, okay? So we're going to use raw equals socket file get content. We just get a string. Now we're going to do data is a map, and we're going to do data dot sid equals the first chunk of raw, which is going to be the first 5 characters there. So we're going to go 0 to 6. Is that right? Wait, hang on a second. I got to 0, 1, 2, 3, 4. So we want 0 to 5 because I can count. Okay, so that's the SID, the socket ID or session ID. Either one you want to call it. The next one's going to be the flag. Okay, so that's going to be, oops, it's supposed to be there we go. So that's going to be a single character. And then the sequence, kind of probably seeing the pattern here. Okay. Dot ACK. Okay. Now we don't need the packet length because we're not really doing anything with it right now, but we're just going to grab it anyway, just so we can say that we have it. And that's going to be 2 characters, so it's going to drop off there. And then data.payload is what we actually want. Let's go text. Let's just call it the text. Okay, and that's going to be everything after, let's see, it's data.index of, end of Oops. Sorry guys, let me fix that real quick. There we go. All right, so from 12 to data.end of packet is going to be our message. Once we have parsed all of that, we're going to return the data as a map. It's going to be the data map. And if we want to print the message itself, then we print data.text when we get the map there. And then we can use this onReceive function to return a map thing that we can use for multiple different purposes. So we now have send, and we have receive, and we have a function to increment our sequences or acts. We can do either of those, but you don't increment acts. You match acts to the last sequence you received, but you do increment sequence after you send a message. Does that make sense? Receiving acts, but sending ups the sequence. Okay. Let's just do a really quick test where we're going to first send to the file, and then we're going to receive from the file. So we're going to send a message, and then we're going to print it, which is fairly, basic. So socket.send, we're going to say hello world. There we go. And that is, of course, 5, 10, it's 11, so we got plenty of room left. We're going to print an extra line, and then we're going to print socket, receive .text. Actually, first let's print the whole map, and then we'll print the text. .text. There we go. Oops, missed something. Always form your stuffs correctly, guys. Okay. Because I didn't call it text. I did call it text. Oh. Should probably do socket.receive.text. Alright, let's try that again. There we go. Hello world. Data.index. Oh, okay. One more mistake. There. I'm leaving the mistakes in, y'all, because this is the process. This is the process. The debugging process is part of it. I want you to see it. Okay? So there we go. We have the text isolated from the entire packet. Okay? We can see our flag, our sequence, our ACK, which means that we can do stuff with that later. Okay? So we wrote that information to the file, and then we read that information. So let's change the message. Hello back. Hello back. There we go. Easy enough, and it even preserved that little space right there. So let's pretend that we are synchronized. Okay, so over here we're going to change something. We're going to take flag as an input, and there we go. Okay, so we're going to set the flag based off of what we want, which means we're not going to send sync, we're going to send an ACK. And what that means is, right there before we send the text, what we want is socket.ACK is equal to the data.sequence. Okay? And we'll be using this later to send an acknowledgement of that as soon as we have two different dealios going. Okay, so I went ahead and typed a little bit of this up ahead of time to make sure I was making fewer mistakes. But anyway, what we're going to do here, right here in our receive function, is we're going to enforce ownership of the packet. So if our SID doesn't match the packet SID that we just last read, we drop it. It's not ours. We're not allowed to read it. Okay, so we're going to make sure that that's there. And okay, how do we set the socket ID in the first place? Well, for right now, for testing purposes, we're going to manually enter a socket ID. So you and your peer exchange through some other medium the socket ID, or maybe you're using this for yourself, so you already know. But again, it's just testing, so you would want something more sophisticated. For right now, we're just going to manually enter it. So whether we're the host or not, the only way the user and the peer can sync up is if they both have the same socket ID. So we're going to prompt for that, and then if it's not the correct length, we're going to reduce it, and then we're going to also make sure that we only get the number of characters from it that we want. Okay, so we're just going to get the first 5 characters, and then we're going to dump the rest. Okay, now let's come down here to our send function, and let's fix this part right here. So what we're actually going to do is send our termination signal and no payload. Okay, and we're going to just remove this because we're going to handle that in our actual receive function. Okay, so if it's quit, we send the term, otherwise we send the message. And if we look up here at send, that's basically all we got to do. Okay? Receive, we want to first make sure that we got the correct SID, and then down here, once we get the flag, we want to basically we want to terminate. So we're going to set our mode to quit. We could just return right here. That's completely something we could do. But it's like an extra couple few lines of code that are not going to matter because it's going to drop out anyway. It's not going to print anything, and it's just going to drop out. Okay, so that should give us enough. Let's go ahead and actually let me double check here. Let me make sure. Yes. Okay. All right. Yeah, I think it's going to be good. Okay, let's go in here, and we're going to open it up in one mode. So we're going to say send, and we're going to say it's 1, 2, 3, 4, 5. Oh, derp. Sorry, folks. Gotta remember what I'm doing here. Okay, one more time. Sending. Okay, now we're going to come over here, and we're going to receive. Okay, 1, 2, 3, 4, 5. Text. Okay, I see what I did wrong. Let's go back up here. This and... So these are correct. But if we come down here, I've got socket.sid instead of socket.connected right down here. So let's fix that. Actually, I like SID better. So we're going to actually fix that the other way. There and there. That should change things up because we weren't writing the correct SID. So let us send 1, 2, 3, 4, 5. Send ourselves a little message. And then we're going to receive 1, 2, 3, 4, 5. And it's continuously looping because we forgot to put something right here. Socket.received gets. We'll just do that. Okay, so let's go over here to receive. Okay, and we'll go to raw. Socket.received gets raw. Okay. If socket.receive, or I'm sorry, if, here we go. If raw is equal to socket.received, then return null. Okay. So if raw equals socket.received, which means, let's actually do last, because that's what it actually is. If it's the last file we received, we don't want to print it. We only want to print new writes. So if it's the last message we received, we don't want to print. Okay. Otherwise, we say it's the last one. All right. So let's go ahead and see how that changed. Oh, one almost forgot. Let's see. No, that's send. I'm sorry. Socket print socket.receive.text. Let's go ahead and comment that out. If, or actually, let's do this. Message equals socket.receive.text. Okay. If message, then print message. Otherwise, do nothing. That way, we'll skip anything that's empty. Come back over here. Let's see if our quit function works. Does not. Okay, great. Okay, so I forgot that up here we're actually returning null. So we can't actually get text from null. So what we're going to do is actually that. Okay? And if message, then print message.text. This will be a little better. So let's try that. Receive. Interesting. Okay, now we've got that figured out, we'll remove our debug line. And, whoops, 2, 3, 4, 5. There we go. Now, sorry about all that. Now we can actually hello world. Yay. And we'll just go ahead and simulate two parties receiving on the same socket. Hello. Hello. Which actually isn't going to show up because it's a different thing. There we go. Now we can do that. This is a little confusing because we don't know who's talking. So now we're going to go ahead and put in an identifier so that we know who's talking. So we got socket.nickname is equal to the user input. Please enter a nickname. Okay. That's not how that's supposed to look. That's how that's supposed to look. Okay, please enter a nickname. And then a socket ID. Select a mode. Let's put that in there. Because remember, that was a little not great looking up here. Because the so we go send or receive. And we actually don't want it right there. Forgot about that. We want it at the end, if we were civilized. There we go. That'll look much better. Oh, we still need to print our nicknames. So let's put that here. Socket.nickname. Okay. So we pick that, and then it's going to tack that onto the end. Now when we receive, here's what we're going to do. We're going to print message.nickname plus, let's put it in brackets because that'll look cool. Little bracket. Okay, and then we'll put the message.nickname in there. And we'll do, oh wait, no, we don't want to do that. We want to do that. Okay, now let's see how that looks. Okay, so first we'll see if we can make it quit. Hey, look at that. It almost worked. Okay, so let's clear that out. Clear that out. Clear that out. Clear that out. Let's put a line in here so that we clear the screen. We'll call this pub socket version 0. I think we're probably on 2 by now. There. Much better. Okay. Hey, now we're cooking with fire. Look at that. Okay, so send, pick a nickname, Bob. There we go. And over here we're gonna send. We're burger. Same socket. Okay. Oops, wrong one. Okay. Receive. And this is Bob. Oh, what happened to nickname? Oh, I bet you I didn't put socket.nickname. Did I? Nope, I didn't parse it. Okay. So, what we want is to move this down here. Nickname is equal to whatever we end up with here. So let's really quick, 12 plus 16, because I don't like math. It's going to be 28. So we're going to go up to 28. Unless I didn't math correctly. Let's find out. Oop. Derp. Probably should put that right there. Yeah. Okay. Let's quit out of here. My quit's not working. This thing doesn't want to quit. Okay, so send burger. Okay, and then receive. Okay, here's another mistake I made. This is looking like this because I forgot to pad the payload. Like, we got our pad function up here. I forgot to... Wait, did I even make a pad function? I did not make a pad function. Okay, so I need a pad function. That is... we'll call it text. Socket.pad is text. So while text.length is less than 16, t gets t plus that space. There we go. Return t. Should probably form this correctly. Okay, if you can't tell by now, my brain is prone to short-circuiting and not seeing things correctly. Okay, so socket.pad, we're going to come back down here, and we're going to get socket.pad the message. Okay, and that should allow us to send proper messages. Okay, send en. I missed en. Goodness. Hey, look at that. We're cooking with fire now. Alright, let's get out of this one. And then we're going to send, this one is Bob. Connect to that. A. R boob 5. Okay. Heck. Now look at that. Look at that. We got two scripts writing to one file, identifying who is writing. And if we go ahead and fire up another terminal, open A, we're going to send as Vigo, and then we're going to send to 11224. Okay. Now, and we see, notice 0 updates. Okay. So we cannot interfere with this conversation. And this one, if we open up another terminal and set it to receive, and that was this, that, oh, well, whatever, that's our nickname now. Vigo, and then 11224. Okay. Yeah, okay. So we have successfully created a socket. And what is the thing that makes it a socket? The thing that makes it what we set out and intended to do is the ability to isolate text written to the same medium, in this case a file, and isolate it to such that only the intended recipient can read the text. And you can write to the same wallet, and each is, now this doesn't have resend, that sort of thing at the moment. We've, if a packet isn't read right away, it'll be lost, But at the moment, we do have a functioning socket. Now, to bring it in line with Project SATR, where we're going to use subwallet info instead, we need to learn how to do subwallet info. So that's going to be our next section. Go ahead and pause, grab yourself a snack. We've definitely burned up a lot of brain calories, so recharge, and then come back and we'll talk about subwallet info. And then once we know how to do subwallet info, we will port our socket to using subwallets instead of files. Okay, so let's take a look at what our socket looked like. The last write was from Vigo, as you can see here, and that was Vigo's socket ID. And we, as yet, have not been put written code to increment these guys and have them written. So right now, there's the payload, and Vigo wasn't getting any ACKs, and he didn't send any sequences. Now let's go over here and send a file and then check again. Now there's Bob's packet. Okay, you can see that and all that. Pretty cool, right? Okay, so let's fix a couple of things. Now we've got some of this stuff straightened out. Let's go ahead and fix, first off, this not quitting when we tell it to. All right, so we're going to go up here, send term signal, send term, and you can see it says if the flag is not S, then up the sequence. But the flag starts off at S, and when we send the flag in, we never set our socket to that flag. So here's what we're going to do. If it is equal to that, then what we're going to do, if flag is equal to that, then what we're going to do is, let's see, return null, else the socket.sequence gets socket up. We're going to increment that, and then we're going to remove my debug line, and then socket.flag gets flag. Oh, there it is. Sorry, guys. I always miss those. All the time. All the time. Okay, so we're just going to call ourselves B. And let's receive. Okay. Oops. Forgot to turn that off. That's another thing, is you got to clear out stale sessions so you don't just get a whole string of terms. Okay, so we got that. And there we go. Good. Now let's test to see. Socket close. Perfect. Now we can close our socket. And of course, we're going to need some sort of way to purge stale sessions, one of which would be just using a different socket ID than the last time. Obviously, that would, that would do it. So let's go with the same nickname, different socket ID. Okay. And there we go. And now it's not terminating automatically. Perfect. Let's go ahead and terminate that. Okay. Now you've got a functioning socket that can do enforce packet ownership, and it can terminate itself appropriately, and then you just switch to a new session ID so that the last one remains closed. You can't re-enter that last session. Okay. So with this, you've got all the parts, and all that's left is to do subwallet info. Okay, so now for the next part, we're going to talk about the blockchain and subwallet info, that sort of thing. So first things first, you're going to use include lib, like we're used to using for including a .so, like metaexploit, apt client, that sort of thing. So the blockchain has its own API. It's right there. It's got the block symbols. See it? It's got a few different things, but the first thing is getting the coin itself. Okay, so you can log into your wallet, do all kinds of stuff, but getting the coin is what we're going to do. And doing so requires the name of the coin, a user, and password in order to log in. Now, I'm not going to show you the username and password to log into LeetCoin. I hope you can understand why. Okay, so I'm going to cut away, replace the user and pass with the correct info, and then build this to show you what we're going to see. Now, once we get the coin, once we log into it, we use we have the coin there, and we use get subwallet to get the specific wallet we want to get, which is in this case LeetComs, and from there we're going to get info. So this is kind of like getting a file named LeetComs, and this would be like getting the content of that file, and then we're going to print it. So let's go ahead and do that. Come over here. Oh, right. It said that because I didn't. Let me cut away and build it real quick. Okay, so we went ahead and built this, and I did the user and pass off screen. So we build that, and it prints the info, and the info of that particular subwallet looks like this. So this is a public wallet ID. Or public wallet address, rather. This is the join date when the account was created. This is the main wallet ID. So you'll see this when you buy coins from me. This is the wallet that I'm selling them out of. So you'll see that on the stocks.exe. That's me. This is for your insurance. This is reserved later for like stuff that you can buy through credit, like different services, that sort of thing. And this is going to be where you can have a custom nickname for your comms client. Now this right here is the packet for comms. Our packet is a little more complicated than the simple one we're building here. But the basic structure is the identifier, signal grayhack. GH is for GH socket. This is the version. We're on version 0. This is the signal, or the flag rather. That's term. This was the session ID, and this was the last sequence, that was the last ACK, and payload size. Last payload was empty because it was a term signal. This is the public ID of the intended recipient. Remember, session ID has to match, but also with this one, intended recipient has to match as well. And then you've got the data was sent, and then the status of the port. This is all just debug info. This isn't actually used by the system. This is just so I can read it. Okay, but that's what the subwallet info looks like if you have a LeetCoin account. They start off empty, so it's whatever the coin creator decides it should look like. But this is how you see it. You just simply get the coin, you get the subwallet, and then you get the info, just like you would get a computer or file object by name and then get its info. Same difference. So in order to plug this into here, it's basically just porting this in. So we're not going to use a socket file. Okay. Not going to use a socket file. And then, so down here, we need to single that out, because that's what we're going to replace with setInfo. And then up here, comment these two out, because we're going to use getInfo for that. So let's do setInfo first. Well, actually, let's get the object first. Okay, so let's just port this in. Okay, we're going to copy that, and let's see, how do we want to do this? We'll do, actually, we don't need to put this as part of the class. We can put this outside. That's not going to be used for very much. But we can do this, socket.coinName.coin user and socket.pass. So we'll say cuser and cpass. Okay? And then socket.coin is going to be equal to blockchain.get. Sorry, guys. This is going to be a constant thing for me if you guys ever just watch me coding live, or just on the fly, not constantly going back and re-recording. Okay, so socket.coin is, once we log into it, we've got the coin. So we can get rid of that. Okay, and now finally, we'll just call it host. That's going to be socket.coin.get subwallet. We're just going to put it right here. We're going to put it just right here. This is actually the bad spot to put it. That's a bad spot to put it. Yeah, no. I think we'll just put it right here for now, because it's always something we can change to later. So what we'll put here is leetcoms. That's one wallet that we want. And then socket.peer is going to be we will use the leet gaming subwallet. Yeah, that'll work. Okay, so we have a coin, a host, and a peer, so we know which wallets we want to look at. So we're going to go down to our send, and we're not going to use set content anymore. We're going to use socket dot what did I call it? Host dot set info packet. Okay, and then for receive, instead of get content, we're going to use get info. So it's going to be socket dot well, for now we'll do host and then we'll do peer afterwards. Okay, so socket.host.get info is going to be raw. And then actually we want to keep this. We want to keep that. There we go. So we're going to get the raw data out of the subwallet of the host first, and then we're also going to get it from, we're eventually going to change this to say which one we want to get it from, but that's fine. All right, so raw equals socket.host.getInfo. And then from there, we're going to do the same thing as we did before with the raw data. The only thing that's different is that we're using subwallet instead of file. Okay, so let's go ahead and build that. Okay, so now I've rebuilt it with the correct user and password credentials and built it. The reason why it actually messed up because I didn't put the correct coin name in. I had C user instead of coin name. So make sure you double check your own code, and if you're following along, and change that up. But I built it and then ran it, and now we're back to what we're used to. So let's go ahead and open two of them. We're going to have send for one, and we're going to call him Bob 2345. Okay. And I probably should have maybe used a different session ID than last time, but oh well. Okay, so 1, 2, 3, 4, 5. Okay. And there you go. Now notice we're not using a file anymore. We're using subwallet info. So let me pop on over. All right, let's take a look at that info. There we go. Okay, let's say hello world. Okay, we said hello world. Let's go ahead and look again, and you can now see hello world was sent by Bob. Look at that. Okay, 0, 0, 0, 2. That would be us incrementing. It looks like it's incrementing sequence instead of ACK. I'll have to take a look and we'll see why it's doing that. Socket.flag else socket.sequence. Aha! Okay, here is an important thing. Sequence is supposed to go before ACK in a typical protocol such as this, because you look at your sequences and then you look at your ACK. So that's why it had these out of order. It should have been 0, 2 over here and 0, 0 right here. So it did track the sequence correctly. It just didn't, I just didn't have them put in the correct order. But if you just switch the sequence first and then ACK second, then it'll work properly. But again, you can see we're not using a file here. We're using subwallet info. All this file stuff's commented out. And it's just getting a coin, right? You just get your coin. If you own your own coin, this is how you can't really use someone else's coin unless you have their user and password. If you own your own coin, you can install something like this into it. Just get your coin, get your subwallets for yourself and for your peer, and then just read from them. Have each person, pull your subwallet to see what you're writing, right? And then your own subwallet to see what you're writing, and then display them both in the same window, like we had before. Okay, so let's go ahead and do that. Let's go ahead and have two instances of this. I'm going to have to rebuild this so that these are reversed. Technically, you should be using user input. So we'll do that. We'll do it a little sloppy. This part right here should not be done this way. But we're just going to be a little sloppy with it. It's okay. It's okay. I won't tell anyone. You won't tell anyone. We'll be fine. Okay, so you're going to enter your subwallet name, and then it's going to be subwallet user input, enter your peer subwallet. Okay. Subwallet, not wub wallet. Not we're not making dubstep wallets here. Not today. Okay, so we're gonna go ahead and take a username, and if it's not a correct username, it's gonna barf on us. But that's what we're gonna do. We're gonna go ahead and do that. So I'm gonna cut away and rebuild. By the way, just want to let you know that should put if socket.mode equals q, then exit goodbye. That way it doesn't have to go through all of this before it exits. So just put this line right here, line 90, and you'll be good. Okay, moment of truth. Oops. Gotta clear out of there. There we go. Press enter. Press enter. Press enter. So here we're gonna go leet comms, right? And over here we're gonna go leet gaming and leet gaming. Okay, and then our peer over here, leet gaming. Peer's leet gaming, and then over here, leet comms. Lead comms. Okay, so this one's going to receive, this one's going to receive, this one's going to send, and this one's going to send burger, 1, 2, 3, 4, 5, 1, 2, 5. Oh, wrong one. Okay, so these are both still reading their own subwallet info. So let's go peer. And we don't have to restart our senders to restart our listeners for this particular purpose. Okay, so I once again forgot to build with the correct user and pass, but we're good now. So leet comms, leet gaming, receive 1, 2, 3, oops, 4, 5. Okay. Over here, leet gaming. Okay. All right. So transmission. Hey, from Burger. Hey, from Bob. Pretty cool, right? Now, that's not entirely useful because we want to be able to see both ours and our peers. So let's go back to receive. Raw equals socket.peer.getInfo, right? So what we kind of want to do is have like a second one that looks for our own. Okay. So let me see here. Down here, if we're reading, we want to say socket.receive, socket.host, and then message equals socket.receive, socket.peer. We want to clone that line right there. Okay. And we go back up here to our receive function. Okay. And this is going to be subwallet and subwallet. And there we go. Now we can dynamically decide which one we want to get. And I did it again. I was going to build without the right password. All right, hang on. Okay, now let's see how that changed things. Gotta do that number. There we are. Okay, so there we go. Leet comms. There we go. Leet gaming. And we're going to send as Bob. And we're back to 1, 2, 3, 4, 5. I'm just going to go ahead and send that. And then we are over here, Lead Gaming. And we want to talk to Lead Comms. Okay. And down here we open up our receiver. Oh. Okay, one flub we kind of made was we're checking this twice on 2 different wallets, which means it's always going to be a different check every time. So what we need to do is separate those out. Like last received is great and all, but we also need last sent. Okay? So what we're going to do here is have a conditional. Okay? If subwallet get user is equal to socket dot host dot get user. Okay, if we're the host, if it's ours, then we're checking what we've sent. Okay, so ros subwallet dot get info. We're going to check that first. Okay, there we go. And if we're the host, then we're gonna, do this number, sent, then we return no. And that's gonna go right there. And otherwise, we're gonna check to see if it's the last received. Okay, so it's not the last sent and it's not the last received. Then we add, oh, actually, hang on. Okay. There we go. Okay, so if it's our packet, if we're reading our own packet, we're gonna if it's our own packet, we're gonna return if it's the last one we sent. We're just gonna return null and not do anything. Otherwise, we're gonna add it to the last one we sent. Keep going. Okay. Now, if it's not us, then it's our peer, in which case we received it. Go. Actually, we'll just do that. If we're all equals socket dot last underscore received, then return null. Okay. And we can actually shorten this and this. Okay. And then just do that. So if it's the host and it's the last one we sent, we do nothing. Otherwise, if it is the host and it's not the last one we sent, then the last one we sent becomes the one we just received. And if it's not the host, it's the peer subwallet, in which case, if it's the last one we received, we return. Otherwise, soccer.receives equals raw. Okay? And since this is a return right here, it's a gate clause, we don't need the else. Okay? But that's going to handle that part. We want to go up here to our socket, and we're going to add another last sent equals that, and then socket.last received equals that. Okay. So now, since when we're sending messages, we don't need to actually keep track of that because this isn't doing any reading whatsoever. channels. It's just the receive that needs that information. All right, let's rebuild. Whoops, real quick. You probably already caught this, but I forgot a then up there. So sorry about that, guys. Just double check that. There we go. Okay, so now we're ready to send a message. So we'll say hi there. Okay, and then we say hello, and ta-da! What do you see? You see a live chat between two different people, two different subwallets that do not need any sort of secure shell connection, FTP connection, or any other kind of connection. It's solely through the blockchain. These scripts can be running on completely different machines. All 4 of these scripts can be run on completely different machines. So, definitely here I'll go ahead and put this there, and I will link this code, this exact code that we have finished, in my GitHub. I'll put a link down in the comments there, or in the description rather, so that you can grab this for yourself, experiment, expand, and do all kinds of cool stuff with it. We didn't do much with like Axe and stuff like that, but you did kind of see how that would work. And then you can incorporate that into your own system, like printing them out, that sort of thing. And they're mainly for retries. Like if a packet is not ACKed, then you need to resend it. And that's your homework. That's your homework, is to have some sort of resend system, like where you know, based on the ACKs that you received in the sequence that you're at, that you have not received all the packets and that you want to request the last packet sent. Okay, so one more time, I'm going to stop here, line 32, go ahead and pause, copy. Okay, I'm going to scroll. There's line 32 right here, line 61 here. Okay, I'm going to scroll. Line 61 here, line 91 down here. I'm going to change that to 0.2 because I think we've done enough to upgrade. And then finally, line 91 here, end of file down here. Oh, let me do that. Okay. Scroll back up. Just kind of give it to you a little bit at a time. And again, this will be on GitHub, so you don't have to copy it like this. But that's it. That is our basic Scocket version 0.2. Pretty cool, huh? Experiment with this, throw back to getting the file object instead, so you can experiment with that if you don't have a coin made yet. But yeah, with something like this, suddenly every player's crypto coin gains relevance. Even if it's not a currency, it's suddenly a chat program, just like that. And you can use it for more than just chat. I mean, once you can send socket information, you can send whatever you want and run all kinds of, you can have a database that you can access, all kinds of cool stuff. Okay, so that's it for the lesson today. I know it was kind of long, but a lot of cool stuff to learn and experiment with, and I hope you did learn something. And just the last part of the video, if you want to stick around for it, is just me plugging different channels from different Greyhack players that also have good stuff that you can learn from. Okay? Alright, stay punky, stay cool, and keep on learning. Bye. Right, so the final part of the video I want to plug, I just want to let you know there's a bunch of other Greyhack channels out there to look at that do things way different than me. So a fascinating chap. A lot of you guys probably heard of this person. Did a greyhack video a little while ago, but still worth watching. Greyhack Gaming. Those videos are from a few years ago, but they're all really good. They're all introductions on the state of the game back when they were written, so a lot of stuff has changed, a lot of stuff's out of date, but you can still get a lot out of that channel. There's a lot of content there. Inside Gamer did a couple of these. Chris MIA did one. I can't remember exactly when that was. I think it was like a year ago. I've seen this person in game a few times though. Manny Medina has got some gameplay videos. And it's a tutorial, by the way, so that's definitely one to take a look at. Let's see, Maddie 1959. There's more Greyhack Gaming missions. Of course, there's my channel, Punkworks. You know, call me Pluto at Punkworks. And let's see, Crippling Gameplays did some Greyhack videos back in the day. Looks like 3 weeks ago was the last one, so definitely there's an up-to-date one. Let's go ahead and pop in there and give them a like. As you can see, I'm already subscribed, so definitely give this person a subscribe. You know, they could use it. And it's a good hour-long video. Lots of stuff in there. You can see how this person plays, how good they are, that sort of thing. Okay, let's take a look at some more. Thug Speedman has endless money and how to protect it. This is talking about Bitcoin, or BTC, which is no longer available in game, but there are a bunch of new coins with different rules, like Leetcoin and Cash and XMR, and there is a BTC in game. It's just different than the old one. It was run by Sabranan. Xanadu, someone I've seen in game a bunch, got a lot of good stuff. Streamed this one, so you could see it live, but you can also catch them in game and in the Discord. Let's see, what do we have? Not sure about this one, but it's for noobs. It was a month ago, so it's recent. Definitely worth looking at. Maho Citrus, legendary player of Greyhack that has since taken probably like a retirement, you might call it, a siesta, but absolutely legendary. You can see them here hacking the snot out of Cash Coin. It's glorious, glorious. Let's see, here's some more of Pluto. There's 0x0. Made one about 6 months ago. This person is in game a lot. Is actually a moderator in the Shell Discord and a developer of extreme talent. So absolutely look at how professional this person is. Okay. Reddit Zero. I have to give a special shout out to Reddit Zero. This person has been so kind as to, he created the Shell Discord for me. Like, I'm not the kind of person that really can handle that kind of thing. He was like, dude, you need a Discord for this. And I'm like, I mean, I can't. I don't know how, like, I can't really upkeep that. I'm not good at moderating. He's like, I got you. And he made the Shell Discord, set it up, and then the people came. The people came to the Discord, and Shell flourished because people had a place to talk about it and get help. And so I owe Reddit Zero a debt of gratitude for how awesome he has been in helping Shell out. And he's done a lot of tutorials to teach you how to do stuff in game, not just with Shell. He has Shell tutorials, but he also has tutorials on how to do stuff without Shell, how to use Graybell so you can install your programs easier. But he definitely has a lot of Shell tutorials, probably more than I do by now. I've got like what am I on, episode 16 now? So he's got a bunch in here. So definitely check out his channel. He's freaking awesome, super helpful, and I'm just really grateful for the help that he's given me. Okay, who else we got? There's Chris MIA again. Oh yeah, 6 months ago. Okay, so he's got a more recent one. Definitely check that out. More from Maho Citrus, and that's not Greyhack. There's more from 0x0. Scott No. Who is it? Thor. Pirate Software did a few Greyhack streams on Twitch, and I think they made it up on YouTube. I'm not entirely certain. Probably not. There's fascinating chat again. So yeah, there's a lot of crippling gameplays again. There's a lot of Greyhack content out there. It's just real obscure because it's a very niche game, and it's not one that a lot of the popular YouTubers and Twitch streamers go after because, like, if you stream it live, you're gonna get hacked. Like, there's streamer mode, but like it's just too easy for people to like stream snipe you, basically. So it's rough. That's why I do recordings where I can cut out any sensitive information and stuff. But I mean, guys, folks, ladies and gentlemen, and everything in between, non-binaries, like, check this game out. All right, it's made for you. For real, like, this is the game you've been looking for. Anyway, that's enough of me ranting. Check the game out, check the Discord out, check these other channels out, and once again, stay punky, stay cool, and keep learning. Bye.